WLAN Pi project update. So we've talked about this through several WLPC conferences now, so we'll kind of skip over a lot of the details and kind of dive into what we've been up to really since last year to this year, and what's kind of changed as far as, on the software side, hardware side, kind of walk through all that. But we've also gotten a lot of questions in the process that we'll try to kind of clear the air on with some of that kind of stuff. And a common question that we get is just, okay, that's great, but what does it do, kind of thing. I like to kind of think of it as like, this is the adult Legos is the way I kind of view this stuff. So we kind of put together the building blocks, and you guys as engineers can mold those building blocks to do whatever you need them to do, right? So we kind of figure out, okay, these blocks all can fit together and work together and are compatible together. And are useful for engineers, like certain Wi-Fi adapters and certain Linux packages, certain Python packages. So we kind of meld all that together, and then you can kind of run with it as you see fit. We also have some useful tools and stuff that have been developed by the community, and there's just plenty of other open source packages and stuff out there that we include in there. So yeah, as wireless professionals in the whole WLAN Pi project, this is built to be a multi-tool for you to kind of mold and use which tools out of that you need. You might need all those tools, or you might just need some of those. But yeah, you can own this, you can build it yourself, you can buy it as a completed unit. They're going to be, we do have some available in the Wireless LAN Pros store. But yeah, you can learn with it. It's an educational tool, so you can learn programming, you can learn Wi-Fi, you can learn, wired networking. And then you can also use it from a development platform. If you're looking to get into development, whether it's software, hardware, things like that, it's a great project to be a part of to get those kind of skills and experience. This is a community-driven project, open source. We got a lot of people in the community. A lot of the people that are here have contributed to the project. It's based on Linux. If you're familiar with Linux, it's Linux under the hood there. It's a single board computer. And it really kicked off back in 2016 at WLPC here, and has evolved, to the point it is today, many years later. Really just started off as just a throughput testing device. That was the first thing we kind of thought of, is like, how cool it would be to just have a portable iPerf server that I can take with me in the field into a customer site and have that kind of closed loop test that we can do. And look where it's, gone from there, many years later. Can do a lot more than just that, and still can do that. But as I mentioned, it's a community project, so there's a lot of kind of core contributors that are dedicating. I like to think of the core team are the ones that are giving up the most nights and weekends to make this project happen. Pretty much all of us have day jobs, and this is just a hobby. Like I said, to most of us, I think it's basically our Legos. We just like to build things, make it work, and if it's useful to other people, great. If just we use it, that's great too. But yeah, there's a bunch of kind of core contributors that, especially leading up to like an event like WLPC, lots of time and nights and weekends and stuff spent together, working through things and getting things ready for you guys. And then there's also plenty of other contributors just over the years, many more than are even listed on here, that have had significant contributions as well, whether it's to the hardware side, the software side. So huge, kudos to those guys. Many of the guys, on the list here, you'll see around the conference. So definitely feel free to say hi and give them a thanks if you found any of those things useful. So what have we been doing? So the main focus of this presentation is around just an update on the project from really WLPC last year to today, and what have we done over the past year with the project. So big focus, if you remember last year, we announced the WLAN Pi Pro, and that was the first with the WLAN Pi project doing anything with Wi-Fi 6E. Really came in right at the start of WLPC, at the deadline there to get all things working, at least to some extent, and some additional functionality has been built with Wi-Fi 6E since then. But yeah, we were just kind of coming in right at the last, the finish line there to get things Wi-Fi 6E capable for that. So since then, now that we had those capabilities, we've been able to learn all sorts of stuff by having Wi-Fi 6E capable tools of being able to scan Wi-Fi 6E networks, being able to profile Wi-Fi 6E capable clients. So I'm going to go through some of that with you guys as well, because there was a lot of interesting things that we've learned over the last year as it relates to Wi-Fi 6E. But yeah, really a goal for us, with the project is, and that motivated us is, a lot of people are saying, like, I need these tools to start learning this stuff, to start troubleshooting this stuff. So our goal with the project was trying to make Wi-Fi 6E tools accessible to all of you guys, anybody that's working with Wi-Fi 6E networking professionals. So that evolution that I was talking about, so 2016 to today, we went through a few different hardware kind of revisions. You can see we kind of parked on that NanoPi Neo 2 platform for many years. It was a great platform until they stopped producing that, and we had to kind of quickly pivot to something else. How many of you guys in the room own one of the Neo 2 based WLAN Pis? Awesome. So I still have them, still use them, still super handy, great to just kind of leave plugged in, low powered, stuff like that. So hopefully you guys are still able to make even use of some of those today. We pivoted off of that platform that was a bit more proprietary. We're on the Raspberry Pi platform, which gives us some additional flexibility. And obviously there's a very large community on the Raspberry Pi side that also helps us with the small community that we have on the WLAN Pi side. So it pairs well with that side. So in 2022, launched the WLAN Pi Pro. That was our first Raspberry Pi device using a Compute Module 4. Very similar, I'm sure everybody in the room here is familiar with Raspberry Pi 4. So we've embraced the Compute Module 4, which gives us some additional flexibility beyond what the Raspberry Pi 4 has, but same brains, right? Same CPU and memory and that kind of stuff in there. And then you fast forward to 2022. That's where we announced at WLPC in Prague was the M4 and R4 units, which is what I'm going to be kind of diving into some more here. But then also we've continued on that of the whole Wi-Fi 6E trend and adding more and more support as more Wi-Fi 6E clients and adapters become available with USB and PCIe, adding the support for those as well, so we have more flexibility than just a single radio. So to get started, it requires actually very little from an investment standpoint. So if you're interested in this project and you want to get started and you have a Raspberry Pi 4 laying around, you technically have a WLAN Pi in the sense that this will run WLAN Pi OS. So that's really all you need to get started. Really any Raspberry Pi that is 64-bit capable should run the WLAN Pi OS software. So that's kind of the beauty of why we embrace that Raspberry Pi ecosystem, is that the hardware is very accessible. A lot of engineers already own this kind of stuff. So there's very minimal investment for you to get started in the project to running the code, contributing to the code, and just taking advantage of the tools and stuff on there. So that's all you really need to just get up and running with the basics. So the new hardware, right? So we've got the M4 and we've got the R4. So these, probably can't see them in the back of the room, but just to kind of display them all out here for you. We've got the Pro, we've got the M4, and we've got the R4. And you'll notice there's some differences, obviously, from a size standpoint, but we'll go through some of the differences as far as a feature standpoint. But that's our WLAN Pi family of devices that we have now that are all Raspberry Pi based, all run the same code, same image. You flash one micro SD card, you can pop it in any of these. It'll boot up, it'll configure itself for this hardware. We've worked very hard doing a model detection type functionality, so that way it can actually tell which device it's plugged in. It'll actually display the model on the screen as it boots up. A lot harder than I thought that was going to be. I thought that was going to be a pretty simple task, but trying to support multiple hardware platforms, even though the brains is the same, just little differences in components and stuff proved to be a lot more challenging than myself and I think a lot of the developers thought, but I'm happy with the result that we ended up with. So the M4 is more positioned for, and that's this guy here, what we would call the leave-behind device. So that's where more you would plug that into your network. It's PoE as the big kind of feature of that one. So it can be powered by PoE or USB-C, but the beauty of the PoE is obviously just a single cable in. You now have power, you now have connectivity to it, and that's all it needs. Other thing I like about this one is we've got the quarter 20 thread on the back here. So you can take this and attach it to something that'll actually stick to, and a network closet, network rack, network switch works great to be able to just hang that off and holds on nice and tight to there, so then you just plug a single Ethernet cable on there and you're up and running. Great for lab, lab type work and everything too. Counseling into your equipment, tons of options and features there. But yeah, you can connect like an external battery to it, just like a battery pack you'd use to charge your phone, Anchor battery pack into the USB-C port, so that gives you that portability as well. If you don't have PoE available or don't want to rely on the PoE for powering the device, and you just need to be able to have access to the unit. Now the R4 is what we call more of the self-build. So one of the feedback that we got from WLPC last year was one of the big things people liked about the WLAN Pi project was the DIY, the community aspect, right? With the Neo 2, we provided the components and the parts list, and you could just go buy all the parts and build it yourself. We kind of lost that with the Pro. It wasn't so much a user-friendly thing to assemble, and very hard. There's a lot of components and a lot of parts that go into that. But if we're going with a Raspberry Pi 4, we only have a few different modules that you need to get it to this point. You can see you got a USB Wi-Fi adapter, you've got a screen, and then you've got the Raspberry Pi 4 as the guts there. So that's a very DIY type solution that gets you pretty much all the same or the main functionality as the other two units as well, at a nice, obviously, price point there too. So the self-build option that we made available based on the feedback from you guys that, we like to tinker, right? So that we wanted to make sure we still included that. So that's why we landed with the M4 and the R4. So you got your DIY self-build option, and then you've got the M4 for those that don't want to tinker and just want the thing to, plug in and work. So talked about the self-build option. You bring your own Pi, you purchase the kit, and then you can download the WLAN Pi OS, and really can be assembled, put together. I built 2 of these right before I came to WLPC, and I think I put 2 of them together in less than 30 minutes. But yeah, you can put these things together pretty quickly and have your own WLAN Pi R4 ready to go and have all these kind of functionalities. These will, I think we have some of the kits, at least the fascia kits, available in the Wireless LAN Pros store. And then also with the leave behind, the M4, we also have some of these available as well, and you can see the price for each of those. So this is the M4, lower cost in comparison to the WLAN Pi Pro. That was the other feedback that we got, was the WLAN Pi Pro was definitely a big jump, both in features as well as in price, from the previous generation like Neo 2 platform. So that was the other feedback is, some people didn't need all the features that we put into the WLAN Pi Pro, but they wanted to be able to have that Wi-Fi 6E tool set, right? So we figured out some ways of scaling some of those features down to at least provide that Wi-Fi 6E tool set available to you guys at a lower price point. So hopefully that kind of fits that bill between the M4 and the R4 to be able to kind of make those a bit more budget friendly. So just to dive into that M4 a little bit more as far as all the inputs and outputs, the kind of technical details on there. You've got a nice 5-way joystick now from a navigation for the front panel menu system, and then a few quick access buttons to pull up some features. But then as far as inputs and outputs, you've got 3 USB 2.0 Type A ports. You've got some LEDs. You've got the micro SD slot for flashing the WLAN Pi OS onto. And then you've got a gigabit Ethernet port that does PoE, as well as that USB-C port for USB-C powering as well. Oh, it also does have an HDMI output, so that's another unique feature to the M4 that does not exist on the Pro. The Pro does not have any HDMI output, so both the R4 and M4 you can output to a display as well, so that obviously opens some other use cases that those devices can be used for as well. And as I mentioned, more and more support for Wi-Fi 6E. So we've expanded some of the adapters. So last year, all we had was the AX210s. Now we've seen a few other Wi-Fi 6E capable devices hitting the market. Kind of hard to get in the US, but we can get some imported in and from other parts of the world. So we've got USB adapters now that are both Wi-Fi 6 and some Wi-Fi 6E support on the USB side. And then also on the PCIe side, we now have both the Intel AX210 chipset as well as the MediaTek MediaTek now has two, the 7920 ones, which is what we have in the M4s, and then just very recently, they came out with the one version above that, which is the 7922, and we have both of those running and supported on the M4 as well. And then we're exploring, obviously always looking to the future, so things like Wi-Fi 7 and stuff have come across our radar. We have some people involved in the project that have some connections with some of the vendors and stuff and getting early access to chipsets. So we're very closely monitoring things on like the Linux side and patches and things like that are going into the kernel to support things like Wi-Fi 7. So we'll be ready to support those adapters once those are available as well. So trying to keep up with all that kind of stuff of supporting the Wi-Fi 6E as those adapters come out, but looking forward to the next generations as well. Anybody have like the new Netgear USB Wi-Fi 6E adapter? That's the first official Wi-Fi 6E adapter on the market to my knowledge. Anybody have one yet? Netgear's Wi-Fi 6E? Okay, I figured we'd have a couple of hands. Yeah, so that one we do have working as well on the WLAN Pi. There is a ComFast one that's very interesting, and we'll talk about that on the next slide here. So some really interesting Wi-Fi 6E lessons learned is how ready are we as an industry for Wi-Fi 6E? And looking back at the last year of all the kind of hurdles we had to jump through, getting Wi-Fi 6E working on these devices, and then profiling Wi-Fi 6E clients and devices that do exist in the world today, it's very interesting to me of some of the things that the devices either do support or don't support. It's not all the same, right? And we're kind of hoping at this point with like Wi-Fi 6E certifications and things like that, that there would be a bit more standardization, but some of the things that we're finding is some client devices don't support 160 megahertz. So we talk about like channel planning and Wi-Fi 6E, and we talk about should we do 80s, should we do 160s? One consideration is going to have to be our client devices, and it always goes back to the clients and what its capabilities are. We found that the MediaTek 7921s, they're limited to 80 megahertz, and that's both on their USB adapters as well as on the PCIe adapters. Even though the PCIe adapters are labeled as Wi-Fi 6E, they are limited to only 80 megahertz. So they will connect on Wi-Fi 6E, or they'll connect on the 6 gigahertz channels, but only do up to 80 megahertz. So some things to be aware of there of some of your clients, again, profiling those clients, understanding what your least capable clients are. Some of the other things that's interesting is some of the clients don't support all of the 6 gigahertz channels. So we've been running into some of that with some of the devices. That's likely more like regulatory domain type implementations is what we're seeing. So that will hopefully get sorted out over time as firmware gets updated and drivers get updated. But yeah, you might run into situations where only the lower 6 gigahertz channels are supported by some of those client devices in your network. So again, having to take those kind of things into your channel planning. We've also seen, very interestingly, some Wi-Fi 6E clients that are marketed and advertised as Wi-Fi 6 clients that actually support some 6 gigahertz channels. So again, with MediaTek, they have come out with the ComFast, or ComFast has come out with the 951 AX and 953 AX. They're both based on the MediaTek chipset, which is 6 gigahertz capable, but they market them as Wi-Fi 6 USB adapters. So on the other end, you could have clients that you think are not 6 gigahertz capable that could potentially be 6 gigahertz capable. So very interesting kind of findings with some of that, because they don't mention anything that the devices support 6 gigahertz, but sure enough, we can actually get them to connect on 6 gigahertz and it actually works. So yeah, some pretty interesting stuff to kind of play around with. Like I said, this is all stuff that we've just learned over the last year of playing around with some of this stuff. But lots of driver firmware bugs, lots of late nights and stuff, and kernel panics and all that kind of stuff that if anybody's worked with Linux and drivers and stuff like that, it's fun to try and troubleshoot and sort through all that kind of stuff, but gotten things fairly stable at this point. Lots of even regulatory domain issues. I've even had some conversations with some folks from different parts of the world this week using like the Pro, which has the AX210s in there, where they go to a certain part of the world, like in Australia, they get restricted on certain channels. They can't access maybe the 6 gigahertz channels, or on 5 gigahertz, they can't do any kind of transmission on 5 gigahertz. They can't do like active scanning, or things like Profiler won't work, which requires transmission. And it just depends on where they are in the world due to like what the Intel AX210 uses is LAR, which is location aware regulatory. So it requires it to scan before it will set its regulatory domain, and it listens for country codes in the beacon, and that's what it sets its regulatory domain to. We can't override that in software, at least that we've found. So if somebody knows a way around that, that might be something that could be useful to contribute to the project. But yeah, those are some of the quirks that we have to deal with, because until that regulatory stuff is updated in the firmware, we have to abide by that in the chipset, right? So yeah, things to be aware of, that may impact your environment, depending on what kind of networks and where those networks are in the world. And you have that AX210 in, let's say, a Windows laptop, you may run into the same kinds of issues with regulatory issues. All right, so features, what can this thing all do? So lots of things we can do right out of the box. As I mentioned, this is kind of a box of Legos. You can make it do whatever you want, but we try to make it easy to do a lot of the useful things. So you can use this thing as a Wi-Fi scanning for local or remote Wi-Fi scanning. Easy scanning for using as a leave behind, or you can access it even remotely using something like Tailscale or Zero Tier, if you're familiar with those. WireGuard VPN options, you can drop ship this to a site. They plug it in, it shows up on your side on Tailscale with an IP address, and you can connect to it from anywhere in the world. Profiler, continue to do updates to the profiler side to support things like Wi-Fi 6E, so we can now profile a device even out of band on, let's say, 5 gigahertz, and many devices will advertise that they're 6 gigahertz capable. So we can run the profiler, we can see all their 5 gigahertz capabilities, but we can also see, is this device advertising it's capable of 6 gigahertz. This was another big lesson learned. We learned just recently now that Apple has some 6 gigahertz capable devices. The 2 Apple devices I've profiled, there's nothing in the association frame that it sends to the AP that tells the AP that it's 6 gigahertz capable. So this is one of those another kind of things that could impact your environment for things like band steering, those kind of things. That's what the AP is hearing, so the AP is not going to know that that client is 6 gigahertz capable. So that's another thing we have to consider with clients and what it's advertising its capabilities are to your environment. All sorts of things for packet capturing as well. That's another very common use case for these devices. If you need to do any kind of packet capturing in your lab or in the field, you can do packet captures on 6 gigahertz. There's now built-in functionality within Wireshark to use these devices as remote packet capture devices, thanks to Adrian and his contributions there, and also with contributions to AirTool, his packet capture tool that he talked about, and then also Kismet also supports these as well. You can use all the adapters that we use in here are also supported in Kismet, so it'll work for a capture device that way as well. We also now have spectrum analysis capability that you can do. We had it locally, where you could plug it into your laptop or something, but now you can plug it into these devices. And in Wi-Fi Explorer Pro, you can use things like a WiSpy DBX or an ASIUM WiPri, and you can get 6 gigahertz spectrum analysis remotely now. So I mentioned you can drop ship this to a site, and you can get that spectrum analysis remotely as well. ASIUM has been also a fan of the WLAN project and wanted to help and contribute. So they offered up a coupon code to anybody that's looking at buying a WiPri. Gets you guys free shipping, and they contribute 20% of each of those sales back to the WLAN project. So a great way you guys can up your tools and contribute to the project that way as well, and help us to fund our habit of buying more adapters and more single board computers and all that kind of stuff. So that goes a long way. So yeah, definitely take advantage of that offer that ASIUM was graciously willing to kind of provide us as a community. So we got the bridge mode. This is a new mode that we've added most recently as far as the modes go. Pretty cool use cases in the field where you can do this as like a cellular to Ethernet bridge. So I could take my phone, connect it to a USB port on the WLAN Pi, and it'll take that as a cellular modem into the device as like a hotspot connection, like if I take my iPhone. We've also tested it with Android devices that will also do this tethering. So you can bridge your cellular connection from your phone into the WLAN-PI and then go out the Ethernet port, right? So if you need to configure some equipment in the field, we're doing all the cloud-based configuration stuff now. You may not have that internet connection easily available yet until you get your switch provisioned or something like that. Now you can easily get that switch online through a cellular connection. And then you can see here in the demo, Jerry was doing a demo showing his camera connected through a PoE injector, and then the uplink is being provided by the WLAN-PI through his iPhone there, and you can see the video on the other side showing that the video was even coming through that cellular connection. You could also use it as a Wi-Fi to Ethernet bridge, right? Often we need to add that as well, so you could connect just the Wi-Fi radio in the device to the network in the environment, and then bridge out the Ethernet port. So obviously your mind can wander there of all the different use cases that might be handy in the field. Kismet, talked about that already. All sorts of support there from Wi-Fi to Bluetooth and many other wireless devices. You can pop in all sorts of other wireless technology, Zigbee or whatever, into the device and the USB ports and sniff that traffic as well. A couple other things of this segment on like WLAN-PIs in the wild. So as I mentioned, a common question we get is, but what can I do with it? Like that's great, it's got all these Wi-Fi adapters and all that kind of stuff, but what can I actually do with it? So we went out to the users and said, what do you do with it? And this is some of the feedback that we got, is some pretty interesting use cases that I thought some of you would get some kick out of. We've got the Monster Pi here, small handheld device with 6 USB adapters, and you'll see the what he's up to next is trying to push this thing to 12 adapters. But the cool thing with 6 adapters that he had said was, Kietel said was 6 USB adapters allows them to capture all the 6 gigahertz PSC channels and the ETSI domain. So that was, that's a handy use case right there if you're doing any kind of stuff in 6 gigahertz. Mark, is Mark here? Nice. Mark has been doing some awesome stuff for quite a while. He was one of the early, really embraced this whole CM4 concept that we were going with, so I was really happy to see somebody that was taking advantage of when we moved to this Raspberry Pi and compute module platform. He's got the CBRS Pi is what he calls it. And I've had even a few inquiries this week of people that are interested in doing some stuff with private LTE. So definitely find Mark. I'm sure he'd be happy to talk all about that and his adventures there. But yeah, figuring out drivers and stuff, I know your pain, so I'm glad you were able to get things up and running. Jake's doing some awesome stuff as well. I know he's here doing a bunch of stuff with just Wi-Fi 6E testing and just having a nice test platform to do scans of Wi-Fi 6E and do packet captures, validate things are working and doing what they're supposed to when you configure it on the radio, make sure it's actually putting things on the air correctly. So being able to remotely manage those kind of things and control everything. Ben's doing some interesting stuff. Ben's been a contributor and developer with the project for quite a while. He's doing what he calls the Mirror Pi, where he's actually taking an iPhone, reflecting that information into the WLAN-PI, and then reflecting it back to the phone, I should say, to be able to display real-time like RSSI information on the device. So we can't display that directly on the iPhone, but if we reflect that out of the iPhone into something like a Linux device, and then we can, through an app, feed that back in, and now you can walk around with those 2 devices, Bluetooth paired together, and see the RSSI live on your iPhone. So if you're interested in something like that, definitely hit up Ben. Pretty cool use case for that. I got the Hammy scan from UC. Obviously, to be named, project as we saw earlier yesterday. But really cool to see, some other developers doing some things with the radios in there and the Bluetooth pairing to be able to display RSSI directly on an iPhone, doing those measurements and being able to record those. So yeah, that is what I've got. That's the time I've got. And yeah, if you want to contribute, definitely go to these links here. We got the feedback.wlanpi.com. You can learn more at wlanpi.com, and then we've also have a Twitter out there. If you're not following that, we try to do updates and stuff through there and share out anything that people are working on. But yeah, if you're interested in this, get the tools. There's some available in the store. Pick up a Raspberry Pi 4. That's all you really need to get started. Yeah, that's what I got. Thanks, guys.